Good afternoon, everyone. First, thank you for joining in, and thank you for your interest in biochar. You've heard from Kelpie Wilson, Jim Archuleta, and several others who have talked about using woody biomass to make biochar. And I want to follow up on that for using biochar for abandoned mineland restoration. And I'm going to talk about near woods or in woods processing to make the biochar to be used for, within a watershed mineland restoration work. I also want to thank my co-author, Carlos Rodriguez-Franco from the Washington office, for helping with this presentation. So there are three main threats that we can address by using biochar on abandoned mine sites. First is the threat of forest health and climate change. The second threat that we'll be talking about is how to use small diameter woody residues that have little or no value that are often burned in slash piles and are really a pollution threat and a soil threat, but have really no value for ecosystem services except for reducing wildfire risk. But part of the problem with this open burning has also been that we don't often have a window where burning is permitted, and so these slash piles are often in the woods for years and years without anything happening to them. And finally, the third threat is abandoned minelands, many of which are not contaminated, but certainly produce erosion and have little vegetation because of the lack of soil organic matter. So in all, what we're trying to achieve is restored ecosystems, rural jobs, and decreased wildfire. So the first threat, forest health. We have a longer and more severe wildfire. No one should be surprised by this map that I'm showing that was built in August. We have a lot of overstocked stands that haven't been thinned for various reasons. Fire suppression has, for the last 100 years, has really changed the structure and dynamics of most of our forest stands. And in a lot of cases here in the western United States, bioenergy markets don't cover most of the area that we would be harvesting timber from. And again, I have to mention that this small diameter material is not valued and that there's limited acceptance of prescribed fire. The second threat, of course, is what do you do with this woody residue? There are a lot of acres impacted from hot, concentrated fires. You can see from the slash pile how large these areas can be. This is small compared to some that I've seen in the forests in the west. And you can see in this air photo, the little white dots within this red outline are old slash pile burns. These scars are 50 years old. Nutrients have been volatilized. There's been a loss of organic matter. There are few trees or shrubs. Woody vegetation of any kind is lacking. The soil has been impacted so much that the fungi and bacteria have changed within the soil and really no longer support ecosystem services or vegetation. And in a lot of cases, these areas are covered in invasive species or nothing. So this is certainly a threat to productivity and in ecosystem services. The third threat is abandoned minelands. There are huge areas in the western U.S. in particular, but also in the east that have either had hard rock mines from early settlement times until now, and there's also now in the east and some in the west, the hydrofracking where wellheads have been left abandoned and are no longer productive. So most of these sites are barren of both soil and plants. The restoration needs are huge, and many of these sites are producing degraded water quality, erosion, both wind and water, and they often are a human health concern. You can see the soil, the soil, in quotes, the soil is often just rocks. And so there has to be a huge effort to rebuild the soil profile. And I'm going to talk about that in an example in a little bit. So how do we address these multiple ecosystem threats with biochar? One is that we can build soil resilience. We can contribute to site sustainability, address long-term productivity issues, and increase the resistance and resilience to climate change. Part of the goal for the Forest Service has always been that as we restore these ecosystem services, we can also contribute to clean water by increasing the quality and quantity of water that leaves forest sites. We can improve rural economic activities by creating rural jobs, decrease the risk of wildfire. This certainly opens up the opportunity for more recreation and other services that these sites can provide. So abandoned mine restoration costs, many of these sites, cleanup could exceed 20 billion, but that's mostly on Superfund sites. There are 50 Superfund sites in the United States as of 2015. But on the other hand, I think we need to think about what is the cost of these lost ecosystem services, of poor quality water, of lost hunting or fishing revenues, and the loss of forage or tree productivity in the future. So, I think we have to think about weighing the costs and the benefits that are associated with this mineland restoration work. So how do we do it? We've talked a little bit this morning about some local opportunities for making biochar near the forest, and that could also be used on these in-holdings that are abandoned mine sites. So one, of course, is slash pile burning, and we can build slash piles that have a limited impact on the soil, and we can quench the fire, quench the coals once they're done burning, and build some low cost and limited amount of biochar. This probably isn't enough to do some extensive mineland restoration, but you could do some burning on site and rake it around and get a little benefit there. I think one of our other opportunities is to make kilns. Kelpie talked quite a bit about this. Kilns are also a low cost way that we can employ a local workforce to help us make biochar. Some kilns are much larger, and so you would need some heavy equipment and, of course, water to quench the coals. Some new equipment that's come around in the last several years is this Tiger Cat carbonator. It moves across the site, can be used in woods. You would need a grappler to load the wood, probably a forwarder to move wood to the equipment. And then, of course, you'd have to have water on hand to quench the coals. You'd probably want water on hand for all of these operations since we're dealing with fire in a forest ecosystem, right? And lastly, I want to talk about this new char boss that's been developed by AirBurner and was a joint effort by the Forest Service and AirBurner to build an in-woods mobile unit that could make biochar 24 hours a day, 7 days a week. We just tested it this week, and this has been it's been a huge success. We've been able to load it, burn cleanly, and produce biochar all day if we wanted to. So again, this all of these pieces of equipment can help build a rural workforce. It's just these methods that require equipment means that you have to have some sort of investment at the very beginning to get the equipment on site, and some equipment that could move the biomass into whatever piece of equipment that you would choose. And then, of course, there is some depending on how close you are to the mine site, there would have to be some transportation from the forest to the site. And how do you spread it once you get it there? So the Forest Service also developed this biochar spreader. We used it successfully on forest sites, but could also be used successfully on mine sites. It's pulled by a log forwarder here in this picture, but could certainly be pulled by any other piece of equipment that you have on hand. It has a grapple to pick up. We use it to pick up super sacks, but you could also load it with a front end loader. And you could use any other kinds of equipment. Fertilizer or manure spreader, a hydro mulcher could be used. And so whatever is on hand, a lot of times on these mine sites, it's just small sites that are amended. And so you could do it by hand or smaller pieces of equipment like a bobcat. So biochar production on public lands you know, is a win-win all the way around. We can work on those abandoned mines that are located in or near national forests. We are increasing the pace and scale of harvest operations on national forests, so we have a lot of woody residues that could be used. It's an easy source of feedstock to make biochar, and we have a lot of methods for making biochar at a moderate scale that could be used near or on site. So how much biochar would we need? Well, you know, optimistically thinking, we'd want to increase, you know, the zero organic matter mine tailings to about 2%. You know, that would take a lot of biochar per acre and a lot of woody feedstock, since the conversion rate is usually, you know, 15 to 50% depending on the method that you choose. But you know, the rates of application are around 10 to 15 tons of biochar per acre are ideal. And maybe you don't add it all at the same time, or maybe you target your applications to biological islands where you could plant some desired species, get them established, and then begin to grow those islands out onto the site so that you're actually putting the native species that you would like to target for your restoration. You know, start small and then grow those operations to a larger scale. Or this could be part of an engineered soil stabilization process. So I want to just briefly touch on a few examples of biochar use on abandoned lands. This one is one of my own, and we did some terraforming where we wanted to build basically soil. This was a pretty rocky site. It was large tailing piles that are dredged from waterways to look for gold in the streams. So there was extensive hydraulic activity, loading, dredging mine waste, and so the Forest Service had restored this stream, but there was little vegetation cover on the surrounding areas, and so we wanted to go in and see if we could improve vegetation cover. We used wood chips and biochar and biosolids from the Bend wastewater treatment facility, and these in combination produced the highest amount of cover, but it took about 2 years. We really couldn't dig this into the soil because it was so rocky, and so we just surface applied, and you know, over 2 years we were able to effectively increase soil moisture by between 15 and 20%. Here you can see how rocky it is. A second example is from some work that Chris Peltz and Andrew Harley had done looking at the upper Animas Basin in Colorado, and they used biochar created from dead trees, converted it to biochar in a pyrolysis unit. Some key findings were that, of course, it increased water retention, it decreased iron and aluminum in the soil solution, and increased cover. So, you know, I think you'll see that there's a theme here for what we can achieve with some biochar applications on mine sites. The third example is the Ruby Hill mine. This was also some work done by Peltz and Harley. You know, the limiting factor was aridity. It's in Nevada. They get very little rainfall. They had sterile soil, and so they incorporated biochar that was made from juniper and pinyon. And they were able to establish a perennial plant community by changing the water holding capacity in the soil. Another example is from Northern California, the Plumas National Forest and the Walker Mine. Once this mine was abandoned, it left behind tailings that were sand, silt, clay, almost like a silica. The problem here is that when the wind blows, the silica dust gets up in the air, and you know, it's really a site that the Forest Service has warned people not to enter because the dust is so bad. And so they've been testing biochar mixed with compost, soil, clay, fertilizer, lime, wood chips, whatever they could find. And you know, again, their best benefit was that there's an increased water holding capacity. And finally, my last example is hydrofracking. This work was done just this year and talked about how when we reclaim these areas, we can change the ecosystem benefits. And you know, this reclamation of wellheads in Arkansas alone would produce an increase of $2 million per year in revenue because of a change in agriculture, timber, carbon sequestration, wildlife, hunters and fishermen, and a change in pollinator species. And so, again, the biochar can decrease the bulk density of the soil, increase porosity and water holding capacity. And so, I think when we talk about these changes, from the Forest Service point of view, we talk about the ecosystem services that we can return to these sites. But it's not just that, right? We can increase soil carbon, water retention. We can build that sponge back in the soil. We have climate benefits, and we also can talk about carbon mitigation dollars. So in summary, I want to point out that, biochar can be made effectively near abandoned mine lands with trees from public lands. And yeah, there are a lot of different methods we can use. I think part of it, trial and error, is just finding what works best for whatever site we're on. But the benefits are huge. We can reduce wood volume, so we reduce wildfire risk. We can improve soil quality and provide vegetative cover. We can certainly reduce wind and water erosion from the site by having that cover. Another bonus on contaminated sites is that we can reduce organic and inorganic contaminants. And there's been a lot of work on designer biochars that can really target whatever contaminants might be on a site. And, this solves the problem of excess biomass and what to do with it. And, it has no value. And if we could use that no value wood for a higher value and employ people to do this restoration work, I think, I think we could be a win-win all the way around. So moving ahead, the Forest Service needs to work with mining operations at the beginning or during the time when they're thinking of shutting down, so that we can work with them to think about biochar ahead of time, get that stockpile mixed with compost, so that when they get ready to do the restoration work, we can be ready to go. In a lot of cases, we don't have that opportunity, and so I think, as a public land agency, we just need to be able to have the tools at our disposal to be able to go in and do this work, with a limited cost, with a local workforce, and be able to start to do some restoration work on these sites. So I want to thank you for listening. I think this has been a wonderful opportunity to chat with you all, and I hope that if you have any questions, I'll be available at the next session when we have the questions and answers. Thank you very much.